So how would you, on the test, how did you solve this log equation?
Convert it to exponential.
You convert it to an exponential. That's what you did. So you said 5 to the second power equals x minus 3, equals the argument. And what's 5 squared?
25.
So I get 25 equals x minus 3. Then you did what to both sides?
Add 3.
Add 3. And what's your solution?
X equals 28.
X is 28. That's all you did. That's all you did on your test. Now, solving a log equation becomes a little bit more complicated, though. So this was more the easy log equation. So let's look at this one. Number 2. All right, number 2, suppose you had this. All right, you had the log of x plus 5 base 6, that's base 6 right here, plus the log of x base 6 equals 2. All right, so that's my log equation.
Close quote.
You have parentheses here. So the log of x plus 5 in parentheses. Now, guys, if this one wasn't here, if that wasn't here that I'm covering, then would it be easy to deal with now? Yeah, because if this term wasn't here that I'm covering, then it kind of looks like the previous one. You just changed it what kind of equation? Exponential. So you would say 6 to the second power equals x plus 5. But because we're complicated, because now there are 2 terms that involve logarithms. So before I can change a log equation to an exponential, I have to have how many logs? 1. So what do you think you're going to do here to get 1 log? The product rule. That's that condensing. Remember that we did earlier? That's where you condensed. So that's why we went over those several problems earlier today. So I'm going to write this as what kind of problem? What property will I use here? Product. So that's going to be the log base 6 of what? X plus 5 times what? Times x. And that's going to equal what? 2. So notice I wrote it as x times x plus 5. Now can I change it to an exponential equation? Yes. So that's going to become 6 to what power?
2.
6 squared equals what? All right, so that's where I'm at. Okay, so I'm going to compare what I have now with what I had on your test. On the test, when you change this log equation to an exponential, I really ended up with what kind of equation right here? Linear. Here, when I change this log equation that I'm pointing to an exponential, this really turns out to be what kind of equation? Quadratic. All right. So how are you going to solve this quadratic equation? First of all, you're going to distribute. You're going to distribute. So this becomes 36 equals x squared plus 5x. Then what's the next step? Remember when you solve the quadratic equation, you either use a quadratic formula or you try factoring, but not everyone's factorable. But regardless, what did you have to have on one side? 0. So what do you think the next step?
Subtract 36.
Bring the 36 to the other side and let's put it in descending order. So this becomes x squared plus 5x minus 36 equals 0. Now I'm going to tell you this. Your log equation will be quadratic and it will be factorable. Now some of you still don't know how to factor though. So in that case, you would have to do what? Quadratic formula. But but what is this factorable?
X inside. And then
There's 6 and 6, but that's not going to work.
3 times 12.
9 and 4. 9 and 4. And the last sign's negative. So you see how some of you were kind of spending some time trying to figure out, well, okay, do I need 12 times 3? Do I need 2 times 18? If you're in that situation, then go directly to what? Quadratic formula. Go directly to quadratic formula. The last sign's negative, so that means these signs in here are what? Different. One's positive, one's negative. The larger of the outer and the inner takes that middle sign. So the 9x here, and this is a 4x, so the 9x has to be what kind of sign? Positive. And then once you factor, and this is factorable, this is correct. Once you factor, what property do I use next? Zero factor property. So if I have two factors whose product is 0, then one of them has to be what? One of them has to be 0. So you said both of them equal to 0. So what's x over here? And what's x over here? Positive 4. All right, now listen carefully. This is where once you get to that point, you're not done. Because remember, on your test, you had something like this. You were asked, let's say I had this function f of x equal the log base 2 of x plus 5. You're asked to find the domain of this function. Remember, I can only take the log of what kind of number? Positive. It cannot be negative, because remember, when we looked at it, we put in our calculator. The log of a negative number is undefined. And the log of 0 is also what? Undefined. So it has to be positive. So in your test, what you had to do was you had to take the argument, which is what here? And ask yourself, where is this greater than 0? That's what you had to do. And all you did was just solve this inequality. So how do you get x by itself?
Subtract 5 from both sides.
And so you found your domain. My domain is any number that's greater than what?
5.
Negative 5. Now in your test, you have to write this as an interval, but you did that on test 1, where you wrote an inequality as an interval. So what's this as an interval? There's no equal sign, so what do you have to use? Parentheses, negative 5 to what? Infinity. When finding the domain, do I need the base at all? This could have been 5, the base could have been 8, the base could have been any number, any positive number other than 1. All you need to do is look at the argument and find out where it's positive. So, the fact is this: I can only take the log of what kind of number? Positive. So here's the other thing you got to do. You got to make sure that these numbers don't make my argument negative. So you got to check these. You must check. Those are solutions to this quadratic equation, but are they solutions to the log equation?
Only one.
Which one? Which one do you know is not going to work?
The negative.
The negative 9. Because right away, what's negative 9 plus 5?
Negative 4.
Can I take the log of negative 4 regardless of what this base is?
No.
No, that's undefined. So right away, I can cross this out. Because when I plug it in, it makes the argument negative. Even here, right? But when I use the 4, what's 4 plus 5?
9.
That's fine. This is 4. I can take the log of 4, right? So that's the only answer. So your solution is just what? X equals 4. Now remember when you dealt with these before, on your test you had a rational equation to solve. You had to find the restrictions. And on this particular test, I think it was 2 was x. But that was a restriction. So what did you say in your answer? No solution, because we only ended up with how many solutions to begin with? 1. It didn't work. Here, how many solutions did I have? 2. Only 1 works. Which one works? 4. Now, remember, some of you put this in your test. Some of you said that 2 was extraneous. Remember the word extraneous? Meaning false. So which one's the extraneous root here?
Negative 9.
Negative 9. So that's your extraneous root, which means it's a false root. It satisfies, it is a solution to the quadratic, but it's not a solution to the log. All right, let's do another one like this. So number 3. And number 3, suppose you had log of x plus 6 base 3 plus the log of x plus 4 base 3. And that's going to equal 1. That's going to equal 1. All right. Can I go directly to an exponential equation? Can I go directly to an exponential equation? No. In order to go directly to an exponential equation, you have to have how many logs on one side? 1. How many do I have here? 2. So I've got to condense this. So to condense, I'm going to use what property? Product. So that's going to be the log base 3 of what product?
X plus 6
Times?
X plus 4.
And that's going to equal 1. So the first thing you do is condense. So remember your multiple choice that's on your final? One's going to say expand. What's the other one going to do? Condense. In order to solve this log equation, you got to do what? Condense. Now can I change it to an exponential? Yes. So you're going to say 3 to the first equals the argument. What's the argument? All right, now I'm going to ask you this. What kind of equation is this that you see? Huh? It'd be quadratic. Because if I FOIL the right-hand side, don't I get an x squared? So it'll be quadratic. Oh, by the way, I wanted to go back and show you. I did this by factoring. I meant to do this. I did this by factoring, but for some of you, if you're having a little difficulty factoring this, what should you have done? Quadratic formula. So what's A here? What's B? And what's C? All right, so the quadratic formula says x is going to be the opposite of b. What's the opposite of b? Plus or minus the square root of b squared, so that's 5 squared, minus 4 times a times c, all divided by what? 2 times 1. Okay, let's see with the radicand, with the discriminant. What's 5 squared? All right. Now, when you calculate it, first of all, what's a negative times a positive times a negative? A positive. So, and what's 4 times 36? What is it again? 144 over 2. And what's 25 plus 144? 169. What do you remember about this, 169? Perfect square. No, it's not the square root of 13. It's just what? 13. Remember, 169 is a perfect square. So the square root of 169 is what whole number? 13. So that becomes since 169 is a whole number, you split it apart like this. So on test 1, you said this was negative 5 plus 13 divided by 2, and then negative 5 minus 13 divided by 2. Let's look at this one. What's negative 5 plus 13? And what's 8 divided by 2? 4, which is this right here. See this? Over here, what's negative 5 and a negative 13? And what's negative 18 divided by 2? Which is this one. All right? So if all else fails and you're having difficulty factoring, then go to the quadratic formula. Now, let's go back to the number 3. What kind of equation is this? Quadratic. So if I'm going to solve this quadratic equation, I can always use quadratic formula or I can factor, but not everyone's factorable. But regardless, what must you have on one side? 0. Before I get to on that side, what do you think you may want to do here? FOIL. Okay. So 3 equals x squared. What's the outer? What's the inner? And what's the last? Combining our terms, I get 3 equals x squared plus 10x plus 24. And then finally, let's put it in general form or standard form. So I subtract 3. And I get 0 equals what?
X squared plus 10x
Plus 21? All right. Now, the one in your test is factorable. So those of you, you can factor this very quickly. For the rest of you, let's just go ahead and use quadratic formula. What's A? 1. What's B? And what's C? All right. So x equal the opposite of B. What's the opposite of B? Plus or minus the square root of 10 squared minus 4 times A. What's A? Times C. All over 2 times 1, right? What's 10 squared? All right. What's 4 times 1 times 21?
84.
So 100 minus 84, is that right? All over 2. What's 100 minus 84? 16. 16 is a perfect square, so the square root of 16 is going to be what? 4. So I get negative 10 plus 4 divided by 2, and then negative 10 what? Minus 4 divided by 2. What's negative 10 plus 4?
Negative 6.
What's negative 6 divided by 2?
Negative 3.
Okay. What is negative 10 and a negative 4?
14.
What's negative 14 divided by 2?
Negative 7.
All right, so that's where I'm at. Okay? All right. Now, if you had factored this, you would have gotten, right here, those of you, you would have gotten x plus 3 times x plus what? 7 equals 0. That's what this is. And then you set each one equals 0 and you get these. Okay? All right. Now, don't go directly and say those are solutions. Because remember, you are dealing with logarithms, and I can only take the log of what kind of number?
Positive.
Positive. Now, be careful, because somebody's going to say, well, they're both negative, so I'm going to cross them out and say no solution. That's not what I mean. You got to make sure that when you check, that your argument is still what kind of number? Positive. So let's check negative 7. Let's check negative 7. Now remember, these are solutions. Those are really solutions to which equation? The quadratic. But I'm trying to find the solutions to the logarithm, to the log equation. So it's kind of like when you solve the rational equation on the test 3 and test 2. Sometimes you introduce extraneous roots. So when I plug in negative 7, right away I know I can't use it, because what's negative 7 plus 6?
Negative 1.
So I'm taking the log of a negative 1, which I know I can't do. So I can't use it. That's an extraneous root. Now let's check negative 3. All you got to do is make sure that your argument is still what kind of number? Positive. What's negative 3 plus 6?
3.
So I'm fine. You got to check all of them. What's negative 3 plus 4?
1.
1. So I'm good. We're done. So the only solution is what? X equal negative 3. That's your only solution. So don't forget, it's easy to forget sometimes to check. That's why on that test, some of you got almost all of it right, except you've got to check. So you lost two points because you didn't say no solution on your test. Okay? All right, let's look at this one. So let's say number 4. All right, number 4, let's say we had this. Number 4. Suppose we had the log of x plus 2 base 4 minus the log of x minus 1 base 4 equal, and that's going to equal, okay, they have 1 again. All right, they have 1. Now remember, to solve a log equation, you want to end up using the idea of changing it to an exponential equation. Can I go directly change this to exponential equation? No, why not? Because you gotta have one logarithm. How many logs do I have? So now you gotta use the idea of condensing. So let's condense this. The subtraction, so I gotta condense it using what property? Quotient. So it'll be the log base 4 of what quotient? Equal 1. Now can I change it to an exponential equation? All right, now change to an exponential equation. So what's the base? What do I raise it to? And what does that equal? X plus 2 divided by x minus 1. All right, we're almost done. That's really 4 over 1, right? 4 is 4 over 1. This is going to be on your last test, on test 3. What are you going to do? How do you solve this equation? What kind of equation is this? Rational equation. You have a denominator that involves what letter? You have a denominator that involves a variable, right? So what's the LCD? X minus 1. That's your LCD. Just like on the test 3, you had 3 fractions. That one's harder than that one, because that's how many fractions here? 2. So what's your LCD? So you multiply both sides by x minus 1. So this is x minus 1 times 4 equals x minus 1 times this fraction. Then reduce. All right, now here, though, you have 4 times what? X minus 1. So how to get rid of the parentheses here? Distribute.
4x minus 4.
Equal, and that's just what?
X plus 2.
X plus 2. All right, so notice I went from a log equation to, and then I changed it to exponential, which really turns out to be a rational equation, and now a linear equation. So how do you solve this?
Subtract x from both sides.
So I get 3x minus 4 equal 2. What's the next step?
4 on both sides.
So 3x equal
6.
6. So x equals what?
2.
2. I got to check though, right? You got to check. You got to make sure that 2 still makes the argument what kind of number? Positive. So you must check. So you must check the arguments. What's 2 plus 2? We're good. So far. What's 2 minus 1?
1.
Still positive, right? So what's my solution? X equals 2. All right. So I gave you 4 problems.